So now today we will do the exact sampling distribution. Exact sampling distribution. And the first in the category is chi-square distribution. This is a sampling distribution. So before coming to the chi distribution, first of all, we have to define what is chi-square variate. Chi-square variate, it is the square of standard normal variate. It implies if x follows n mu sigma square, it implies then z follows n0, 1. n0, 1. It implies z is equal to x minus mu by sigma follows n0, 1. Then the square of x minus mu by sigma square is a chi-square variate with 1 degrees of freedom, right? Then, in general, if we have an independent chi-square variable, independent normal variates, then standard normal variates, then how you will define chi-square? Chi-square is equal to summation I running from 1 to n xi minus mu upon sigma. It's also whole square. Okay, जी? So where each xi is following n mu I sigma square. They have the different mean and different standard deviation, different variance. So this is a chi-square variate with n degrees of freedom. So this is all about the definition of chi-square variate. Now the next we will try to find what is how to derive the PDF of chi-square distribution. First article is derive the PDF of chi-square distribution. So let's start its proof. So we will do it by the method of moment generating function. In order to find out the PDF, we will use moment generating function because it is the uniqueness property of MGF that corresponding to every MGF there is only one distribution and corresponding to a distribution there is only one MGF. So whatever MGF of a distribution, whatever MGF we can derive, we can tell which distribution it is following. So first method we will use MGF, or you can write the method of moment generating function by method of moment generating function. So what we have given, if xi, I is equal to 1 to 3 so on up to n are independent n mu I sigma I square, right? Now we want to find the distribution of किसका डिस्ट्रीब्यूशन निकालना है काई स्क्वायर का काई स्क्वायर इट इज डिफाइनिंग एज n है तो समेशन आई रनिंग फ्रॉम 1 to n xi minus mu I upon sigma I its whole square. So let us name it as ui square, where ui is a standard normal variate xi minus mu I upon sigma I follows n01. So I hope the first point is clear कि हमने MGF मेथड से इसको फाइंड आउट करना है काई स्क्वायर को. काई स्क्वायर इज रिप्रेजेंटेड एज समेशन ऑफ ui स्क्वायर. नाउ वी विल फाइंड द MGF ऑफ काई स्क्वायर. काई स्क्वायर इज समेशन ऑफ ui स्क्वायर. Since xi's are all independent, ui's are also independent. Therefore, MGF of chi square t. This is equal to MGF of summation of ui square t, which is equal to summation किस में बदल जाएगा? Product में, by the property of MGF, right? M of ui square t. ठीक है जी? और they are identically distributed. Therefore, this comes out to be mi ui square t whole raised to power, because all ui's are IID follows N01, right? So let it be number 1. So now we will solve this. Now M of ui square t, this is equal to expectation of e raised to power t ui square. डेफिनेटली u कहां से जनरेट हुआ? x से. x किसको फॉलो कर रहा है? नॉर्मल डिस्ट्रीब्यूशन को. तो नॉर्मल डिस्ट्रीब्यूशन एक कॉन्टिन्यूअस डिस्ट्रीब्यूशन है. So this is expectation of t of ui square into f of xi dxi. So this is equal to integration minus infinity to infinity e raised to power t ui square into f of xi into dxi. Right? This is in the small form. जब आप इसको integration में लिखेंगे तो ये capital में नहीं रहेगा u. This will be in a small expression. So now let us put the value of f of xi. This is minus infinity to infinity e raised to power t ui square. X किसको follow कर रहा है? Normal distribution को. So we will put the formula of sigma 2 pi e raised to power minus xi minus mu I upon sigma I into sigma square. अब यहाँ पर हमने एक बात आपने ध्यान रखनी, all are identically distributed. It means they all will have the same mean and same variance. So you will not put it at mu I, you will just write mu, and here you will put 2 sigma its whole square. I am writing again. So this is e raised to power 1 by sigma under 2 pi e raised to power minus 1 by 2 xi minus mu upon sigma square, right, into dxi. इसमें से जो कांस्टेंट है वो हम बाहर निकाल लेंगे और देन यू विल हैव into dxi. अब d यहाँ पे this is 1 by you will have under root of 2 pi integration minus infinity to infinity e raised to power t of ui square into expectation of, अब ये किसकी वैल्यू है? ये u की वैल्यू है. सो आप इसको लिख देंगे दिस इज एक्सपेक्टेशन ऑफ माइनस ui square डिवाइडेड बाय 2 इनटू अब u जो है what was u? ui is equal to xi minus mu upon sigma. So what is dui? dui is 1 upon sigma into dxi. So what is the value of dxi? So dxi is sigma into dy. So you will substitute the value of dxi here. So this is sigma into d of ui. So whole expression has been converted into ui. So this, there is again sigma, this sigma will be cancelled out. So we will have 1 by sigma under root 2 pi e raised to minus infinity to infinity e raised to power t ui square into e raised to power minus ui square by 2 into dy. Right? So next, अब हम कॉमन निकालेंगे इसमें से. देखो कॉमन निकल रहा है ui square. So this is equal to 1 by under root 2 pi. बस एक्सप्रेशन को लिखना है तरीके से. This is e raised to power माइनस कॉमन निकाला, 2 एलसीएम ले लिया, 1 माइनस 2t. उसी एक्सप्रेशन को हमने इस तरह से एक्सप्रेस कर दिया, राइट, इनटू डी यू आई, राइट. नाउ इन जनरल बेटा जी, इन जनरल वी हैव इस तरह के इंटेग्रल का आपके पास एग्जैक्ट एक आंसर होता है, बिकॉज माइनस इन्फिनिटी टू इन्फिनिटी ई रेज टू पावर माइनस ए स्क्वायर एक्स स्क्वायर, दिस इज इक्वल टू अंडर रूट पाई अपॉन ए. सो अकॉर्डिंग टू दिस और इसको कन्वर्ट कर देंगे इसमें, दिस इज 1/√2 पाई माइनस इंफिनिटी टू इंफिनिटी ई रेज टू पावर। देखो इसमें ए स्क्वायर है, इट मीन इसको हम लिखेंगे 1/√, इसका अंडर रूट करके इसका स्क्वायर लिख देंगे, ठीक है जी। ये सेम बन गया इंटू डी यू आई। अब अकॉर्डिंग टू दिस ये कहता है 1/√2 पाई, इसकी वैल्यू क्या बन जाएगी, √पाई अपॉन ए का काम कौन कर रहा है, √1 - 2t/2, ये काम कर रहा है, right? So we have just applied the formula of integration this. So this comes out to be, so when you will, so √pi cancel, so when you will solve it, what you will get, 1 - 2t raised to power -1/2. So what we were finding the MGF, m of chi square t is equal to 1 - 2t raised to power n tha, that was m of ui square t whole raised to power n. So you will put the value here, then you have 1 - 2t raised to power 1/2 पहले ही था, ऊपर चला जाएगा, that becomes -n/2, which is the MGF. ये किसका MGF है, which is the MGF of a gamma variate. Gamma variate with parameters 1/2 and 1/n/2, with the parameters 1/2 and n/2. Hence by uniqueness theorem, मैंने सबसे पहले ही बात की कि what is the basic concept to find out to derive the PDF through MGF, because corresponding to a MGF there is only one and one distribution, and corresponding to a one distribution there is only one MGF. Hence by uniqueness theorem of MGF chi square is equal to summation I running from 1 to n xi minus mu I upon sigma its whole square is a gamma variate. इसके वेरिएट कौन सा वेरिएट बन गया, गामा वेरिएट विद, क्योंकि इसका जो पीडीएफ है, इसका जो एमजीएफ है वो गामा वेरिएट से मैच कर रहा है, विद पैरामीटर्स 1/2 and n/2, and having the PDF, f of PDF is always represented continuous distribution है, f of chi square is equal to 1/2, जो उसका PDF होगा वही हम यहाँ पे लिख रहे हैं, tau of n/2 e raised to power -1/2, वेरिएट का नाम chi square है यहाँ पे, right, into chi square raised to power n/2 -1, where 0 chi square है तो 0 less than chi square less than infinity, ये इसकी रेंज आएगी. Is that having the PDF with how many degrees of freedom, with n degrees of freedom. अगर आपने इसको cumulative distribution में लिखना है, so there is another way to write it, dp of chi square, right? So this is equal to 1 by, इसको सॉल्व कर ले, 1/2, ये इसको सॉल्व भी करोगे तो 1/2 raised to power n/2 ta n/2 e raised to power minus chi square by 2 chi square raised to power n/2 -1 into d chi square, 0 less than or equal to chi square less than infinity. So this is the required PDF of chi square distribution. So you have to remember what is f of chi square. This is 1/2 raised to power n/2 ta n/2 e raised to power minus chi square by 2 chi square raised to power n/2 -1 into d chi square. Now there are some remarks. Remark number 1. So what the remark says, if a random variable x has a chi square distribution with n degrees of freedom, then we write, हम कैसे लिखेंगे, अब वेरिएबल का नाम x है तो लिखने में कैसे आएगा, chi square इस तरह से. If x is a random variable which follows a chi-square distribution, so how it can be written as x follows chi-square, and its PDF. And its PDF is given by, अब chi-square को क्या नाम दे दिया, x दे दिया, 1 by 2 raised to power n by 2 ta n by 2, sorry ta नीचे आना, just wait, 1 by 2 raised to power n by 2 ta n by 2 e raised to power minus x by 2 x raised to power n by 2 minus 1 with the values, with the limit, domain की जो limit है वो है 0 to infinity, right? So this is the remark number 1. Now we will go to the remark number 2. Yes, we will go to the remark number 2. If x follows chi square n, ठीक है जी, then find the distribution of, x by 2, or prove that 1 by 2x follows gamma distribution with parameter n by 2. इसका प्रूफ देखिए, the PDF of y is equal, यहाँ पे ट्रांसफॉर्मेशन ऑफ वेरिएबल्स की का कंसेप्ट चलेगा. हमने y वेरिएबल का नाम रख दिया 1 by 2 into x, क्योंकि हमने इसका PDF निकालना है तो हमने y इसका नाम रख दिया. ठीक है जी, सिंगल है तो g of y will be equal to, how you will transform the variable, you will write the PDF of the first and the Jacobian of transformation. So what is the Jacobian of transformation? Only one single variable is there, that is dx upon dy its modulus. So f of x किसको फॉलो कर रहा है, x follows chi-square distribution. इसका मतलब यहाँ पे हम f of x की वैल्यू अभी हमने लिखी, that is 1 by 2 raised to power n by 2 ta n by 2 into e raised to power minus x by 2 x raised to power n by 2 minus 1. ठीक है. और साथ में Jacobian आप डेरिवेटिव निकालेंगे बेटा, dx by dy that comes out to be 2 with the limit 0 less than y less than infinity, right? अब यहाँ पे साथ में आपके पास क्या आ गया, 1 by आपका 2 जो है ये बन गया 2 raised to power n plus 1 by 2. ठीक है जी, सॉरी 2 into ऊपर है, नीचे नहीं है, into 2 है. So this comes out to be 1 by 1 by ta n by 2, right? E raised to power, अब x by 2 का नाम क्या है, what is the name of x by 2, that is minus y. ठीक है जी, x की वैल्यू y raised to power n by 2 minus 1, right, with 0 less than, यहाँ पे पहले x की सारा वेरिएबल y में चाहिए ना आपको, क्योंकि कन्वर्शन ही किसमें करनी है, आपने y में करनी है. 0 लेस, यहाँ पे इंफिनिटी है, 0 less than y less than infinity. So therefore अल्टीमेटली बेटा आपके पास क्या आ गया, व्हाट वी वर राइटिंग, हम gy लिख रहे थे, gy का फॉर्मूला हमने लिखा f of x into Jacobian of transformation, और Jacobian of transformation जो है वो आपका सॉल्व करके क्या आ रहा है, 2 आ रहा है. ठीक है, और f of x की जो वैल्यू आपने पुट की 1 by 2 raised to power n by 2 ta n by 2. ठीक है जी, e raised to power minus x by 2 x raised to power n by 2 minus 1 into 2 और 0 less than, अब सारा एक्सप्रेशन y में भी आपने कन्वर्ट करना है. ठीक है, क्योंकि आपके पास y कितना पड़ा है, हाफ ऑफ x पड़ा हुआ है, राइट. सो व्हाट इज द वैल्यू ऑफ x, x will be equal to 2y, तो आप यहाँ पे पुट कर देंगे. So 1 by 2 raised to power n by 2 ta n by 2, right, e raised to power x की वैल्यू पुट करोगे minus 2y upon 2, और x की वैल्यू फिर पुट करोगे 2y raised to power n by 2 minus 1 into 2. अब पीछे आएगा 0 less than y less than infinity. यहाँ तो भी आपका x चल रहा है. ठीक है, ये हमने डेरिवेशन यहाँ से अब अब बेटा अब इसमें से देखो 2 raised to power n/2 - 1 पड़ा हुआ है, इधर +1 है, ये सारा कैंसिल हो जाएगा। 2 raised to power n/2 इज 2 raised to power n/2 का, ये बेटा ये सारा पार्ट न्यूमरेटर का है और वो डिनोमिनेटर का है। तो मैं इसको सॉल्व कर देती हूँ। दिस इज ऑफ n/2 e⁻² कितना रह गया -y, ठीक है जी, into 2 raised to power n/2 into 2 raised to -1 into y⁻² n/2 - 1 into 2, ये 2 raised to power 1 है, 2 raised to खत्म हो गया, इससे ये कैंसिल आउट हो गया। सो यू आर लेफ्ट विथ व्हाट 1/τ n/2 e⁻² y⁻² n/2 -1, 0 less than y less than infinity. So what is g of y? Therefore g of y follows what? Sorry, g of y nahi, therefore y follows which distribution? It follows gamma distribution। एक ही पैरामीटर आ रहा है इसमें n/2, half of into n/2 only, yeah, half into n. So this we want to prove in remark number 2. I hope the point is clear to all of you.